Welcome everyone. Welcome to Cleantech Live number 4. My name is Cameron, and on behalf of Cleantech Rising, we're really grateful to have you here today with us, spending an hour on your weekday to chat about climate solutions. I hope we're finding you well at this time. I know between the virus and the fires out here out west and everything going on in the world, it's likely that many of us are having some difficulties in our lives, and we just want to say we're wishing you all the best wherever you are. A little bit of background for anyone who's joining us here at Cleantech Live for the first time. Cleantech Rising is a nonprofit advocacy organization focused on supporting the advancement of clean technologies. We produce a monthly newsletter that we've been doing for the last 4 years about the latest innovations in clean tech. And we started Cleantech Live at the beginning of this year as a way to create educational experiences and bring like-minded people together for a more kind of interactive way to connect around climate solutions. So for today's event, we're going to follow the same format that we have in our previous events. And so we kick things off with a 15-minute talk, in this case by Frank Schwamborn of Verdical Group. And then from there, we'll move into about 10 minutes of a Q&A where you'll be encouraged to type your questions that come up for you during the talk into the chat. And Frank will do his best to answer those. In previous events, we've also tried to get any questions that went unanswered answered after the fact so that we could send them out to everyone. And then lastly, we'll kind of wrap up with 2 rounds of breakout room discussions where we'll provide specific prompts based on the topic that we're talking about today are related. And we'll break out into rooms and have some small group discussions on these topics. Lastly, after the show, we typically like to hang out and kind of do one more discussion prompt in the main room and before we all kind of part ways and get back on to our day. So we're so excited to have you here today. And with that, we're going to send it over to Frank to get started introducing himself and kind of dive into the talk.
All right. Can everyone hear me pretty clearly? Just want to double check. We had, speaking about infrastructure, my internet just went out, and so we had to do like this last second change up. So I'm calling through my phone. I hope everything's clear for you guys to hear me. So I think it's just kind of funny as we go into it. We talk about the grid, we talk about buildings, we talk about the future of technology. I myself am having a technological issue. So moving forward, I hope you guys can see my slides. Is someone sharing the slides right now? Okay, great. I hope you guys can hear me. So when I say next slide, we'll just go on to the next slide, and we'll go ahead and proceed with the conversation today. So yeah, today's conversation is going to be on today's buildings, tomorrow's grid. And I'm from Verdical Group. I'm the energy engineer and project manager at Verdical Group. I do a lot of project management, and we take a look at green buildings, lead projects, and I manage the paperwork, I bring delivery of the project and make sure that all the sustainability items are put in. I also do a lot of energy analysis, which takes a look at the energy consumption of the buildings. I look at the way power flows and how heat is transferred through the building, and I try to account for all that stuff and make sure the design that a building gets put in is as sustainable as possible. So that's what we basically kind of do at Verdical Group. Next slide. So Verdical Group was founded by Drew Shula. The name we created ourselves, and it's kind of a play on words, but it's basically just the idea is upward trend, positive environmental impact. Next slide. I mentioned before, these are kind of the services we do. We do certified project management. We also do commissioning, net zero energy consulting, bench modeling, and just sustainability consulting. Next slide. We are 1% for the planet and certified B Corp. These are sort of like certifications and processes that reflect on our company and our values, and we donate 1% of our profits to environmental organizations. Next slide. So this is kind of our impact overall. This is how much waste we've diverted, how much energy we've saved, how many people we educated through our conferences, our trainings and stuff like that, how much water we saved, and how many hours we volunteered. together through all our impact and work. Next slide. Some of our select clients we've worked with, from cities to commercial to you name it. We've had a lot. We've been able to help a lot of companies, and we've been able to do a lot of good work to make our society a much greener and more resilient place. Next slide. So I want to start off the conversation today kind of with this icebreaker. I love this topic so much. I can go on for hours, but I only got 15 minutes to do it. So I will be kind of going a little bit fast, but hopefully, I welcome all questions and we can have a great discussion today. So the question I have for you guys is, if you had to buy a phone today and you can only buy a phone every 25 years, would you get it with or without 5G capability? And we know that 5G is a infrastructure upgrade that is blowing up today. You see it on ads all the time. 5G is the next new thing. We live in an electronic consumer world where you have people lining up for the new iPhone every year, every 2 years, rapidly changing their devices all the time. But our building life cycle is in decades. We change out buildings. Our buildings tend to last around 25 plus years. These are things that don't often get changed up all the time. And so when we look into the future of the grid and we look into future sustainability, today really being set up for the future and the future infrastructure. So this is just like a metaphor, comparisons to 5G network. Next slide. So I want to talk about, here's the photo, of the United States at night, a satellite image. You can see how power is all over the country, where it's concentrated, just to get an idea of like the grid. The grid is like one of the oldest and largest working machines today. It's extremely complex, and it's quite amazing how it operates without relatively little hiccups. Of course, we have weather events like fires and heat waves that are putting a lot of stress onto infrastructure and really showing our vulnerabilities in our infrastructure and grid. Next slide. So here I want to kind of highlight, and I want to give like a really good idea for people to understand like what the grid is kind of built up. And here's a high level view. You are aware, or I'm going to assume that you get a utility bill, you pay your utility bill for the power you use. You are an end user, and you buy that power from a reseller. That reseller is often known as your utility company, whether it's Southern California Edison, PPL, National Grid. You're buying power, you are end user, and you're buying it from a reseller. Oftentimes, utility companies might not own their generation. Generation can typically be like a different company. So there's like these three parts to kind of like how the grid is going to operate. And the idea to like source versus site energy. When you buy power and you look at utility bill and you look at the power that you bought, that is sort of the site energy you've consumed. But it does not include the source energy, how much energy it actually took for all those electrons to be generated, to be mined and brought over to you. There is kind of a gap. And what we can see here in the top left corner is different energy types and their source to site ratios. We can see that for a grid purchase energy, we can see that it takes about 3 times more energy than what you purchase to actually get the energy that you used. So these are important aspects to understand. When we look at the grid, we want to be honest about, how much energy is really being consumed and where it's coming from. Because for every electron that we're accounting for, and for every kilowatt that's being used, and every power that's being drawn, we have to understand that there are consequences to those electrons and the grid carbon emissions that come with it. So under the source energy perspective really takes an honest view and really takes a hold of like what sort of energy that needs to go on. Next slide. So I want to talk about the California Independent System Operator. This is sort of like the overarching organization that kind of owns and controls the grid in California. They're known, you can go on their website right now and you can see how much energy is being demanded, supplied, how much renewables are on board. It's really awesome resource of information. And I want people to be aware about how they enter the fold of things. Next slide. And kind of understand how California's energy is changing and what we're looking for. And so this is the duck curve. This is a really famous curve And essentially what it's saying is that because of how much renewable and PV power we're producing during the day, we have this lack of natural gas or other imported energy that we ignore during the day. We lower our natural gas consumption because we have the photovoltaics. But then as the sun goes down, we have to ramp up our natural gas production, and we kind of get this awkward ramp up, and it puts stress onto our infrastructure. And the next slide, I want to show what the duct curve actually looks like. And next slide. Yeah, so here we see this is a random day that happened, I believe, in May. Yes, in May 28th. This is what California's grid looked like on that particular day. You can see in the green light that's the renewable energy we produce, and the orange light is orange line is the natural gas that's being consumed. And you can see this ramp up. And for every bit of natural gas we're consuming, as of course that's associated with the carbon emissions. And for every power that you consumed from the grid, that required 3 times more energy to produce that sort of same energy that you consumed, which will have 3 times the carbon emissions that are associated with that. Next slide. So these are things that I want to show that how the grid kind of operates here. Here we can see batteries and the new batteries that California is installing into its grid, and you can see where it's discharging and charging here. You can see when the line goes below 0, that's when it's charging up. And then when it's above 0, that's when it's discharging. So you can see in the late morning or the early mornings from like 1 a.m., 2 a.m., even at 11 and 10 p.m., the batteries that we have on board are charging up when there is no renewable energy available except for wind. But most of the energy that we're consuming at night is natural gas. We are trying to store renewable energy because that was kind of like the missing link for our infrastructure. But how we're operating batteries isn't so carbon friendly at all. We're charging up our batteries with dirty carbon emission natural gas. And that's sort of a problem that we need to take a look at as we move forward in the future. Next slide. So I want to talk about grid architecture. So we're going to be talking about what the grid kind of looks like, what it looked like in the past, and what it looked like in the future. So here, next slide, a little bit of animation. This is something you will probably be more familiar with. TSO is the transmission system operator. That's what California ISO or Cal ISO is. They're sort of that overarching grid operator that looks at what's going on the grid. They're in charge of telling you when the blackout will happen. The DSO is a distribution system operator. That is your utility grid, like Southern California Edison. These are the people you typically buy from. And you can see here, it's a top-down approach where how power is just brought down. Next slide. So here, this is what the grid is starting to look like today. Now you see, as you walk around your neighborhood, you might see solar panels being added to your house. You might see, you're starting to see windmills or wind turbines that are being added into the desert or wherever they're being placed. We're seeing renewals being entered into the grid, and we're seeing a DSO having to individually manage like each sort of like account that has the PV. For every house that has PV, SoCal Edison or the utility company needs to manage those accounts individually, and then they have to make it work for their system. But that can only work for so long before things get really crowded. Next slide. We're looking for a future where now we have these microgrids and our communities are working together to produce their own power while working with the whole grand scheme of things. And to essentially, this is going to disrupt the marketplace. And one of the biggest challenges we have right now with infrastructure into the grid is coming with an economic solution or the economic business model to account for all these things and make this work. Because honestly, what I'll describe a little bit later is the problems that we have with density of energy and what a net zero carbon or net zero energy or net zero carbon future looks like. Next slide. But this all has kind of a cost. And one thing we have to also be aware of is that the future of PVs and magnetic drives and EV electrical vehicles have a price. And that is the mining of the earth. And that we have to create these metals through strip mining, and we have to collect these materials, and they have to come from somewhere. And there is a consequence for that. And so the future is not necessarily just about having electrification. It's not just about putting EVs and these high-tech equipment. We also have to go back to the old school thinking of reduce, reuse, recycle. Next slide. Which is where I want to bring up the idea renewable gas, and that the idea that we want to divert waste. We want to take renewable bio sources of methane that's being released and emitted to the air, capture that, and to use those as a source to help provide us the energy that society needs. If you look at the carbon cycle, we want to be able to hopefully cut off the fossil fuel part of the carbon cycle, where we stop using fossil fuels and we operate in a carbon cycle that's much shorter, that operates by diverting the waste that we create, whether it's food waste from overconsumption of food or poor agriculture management to water waste treatment plants. There are plenty of sources of bio waste that we are not capturing and we are just emitting into the atmosphere. And by harnessing those capabilities, we have additional means and methods to produce a cleaner future for our infrastructure. Next slide. So just, I'm going to be running out of time, so just keep going, moving forward. Here in the slide, we're just talking about how there's financial incentives to produce RNG, also about carbon capture. Again, we want to stop using fossil fuels. We want to capture the carbon that's already in the air, reuse it for new fuels that are cleaner and operate in a cleaner carbon cycle. Next slide. So let's get into building tech. So how do we design buildings that operate really well with the future of the grid? So next slide. So here, this is what an ideal situation might work at. This is what you might hope to see in a building where at night we're using batteries, during the day we're using the photovoltaic energy, and then sometimes at night we'll use the grid if we need to, if the battery isn't enough. But there's a little problem with this ideal situation, is how much PV can you fit on the roof, and is it enough for your building? Next slide. We know that there is a limit to how much power we can generate off a single roof, and the taller a building gets, the less power the photovoltaics on that roof can supply to the whole building. So if you have a single-story building, it's pretty easy to put solar panels on that roof and then for that building be self-sufficient. But as you get to a denser city or a denser neighborhood, when the floors of a building steadily increase, 5-story buildings, it's very difficult to make it net zero energy, let alone a skyscraper. So we have this issue where we have this limitation of where solar panels are just not enough in a on a community level. We're going to need other we need other forms of infrastructure to help support a net zero and net carbon future. Next slide. So here's some tech that I want to talk about, and I also take a look at the sort of future of what a building can look like. So electrochromatic glazing. Imagine a building that you live in or you operate or you work at, that it reacts to the sun, it reacts to the weather, and the lighting of the glass changes through sensors and helps prevent sunlight from coming in to save energy from saving heat from entering the building, so the HVAC goes down. Next slide. And that we have a lighting system that now works with the glazing system. So as the glazings go up and we block the sunlight from entering in, we have different forms of controlling the daylighting in the building. These things are communicating with each other. Next slide. And we get to a world where we have the Internet of Things. We have all these things communicating with each other. We have big data, and we have that big data being analyzed by machine learning. So the building itself is learning the things that need to happen. It needs to look at all the different systems in the building, and it's communicating with each other. So as the windows are changing its visibility, preventing sunlight, and this lighting systems are changing, it then communicates to the next slide, to our solid state breakers, where we look at the distribution of power in a building. These solid state breakers are a fairly new technology that are they have the capability of, again, machine learning, processing a bunch of information, taking a look at how power is flowing through the building and reacting as such. And this power communication goes on further to the next slide, our mechanical systems where we have variable frequency drives, where we can modulate the flow of air or modulate the flow of a refrigerant or fluids that work with the heat transfer of the building and how energy is moved and heat is moved through a building, and controlling that. Because we know that if we can control the flow of hydraulics in a building, whether it's airflow or water flow, we know we can save a ton of energy by doing that. Next slide. So, with a combination of these technologies, taking a look at how much photovoltaics we can put on a building, but also natural gas fuel cell or microgrids, having this that works together, that communicates together for a cleaner environment. And I'm running out of time here. This is the last slide, so we're going to move on to questions now. Next slide. So I know I rushed through that really quickly. I hope you guys have any questions, and I'm be happy to answer them at this point in time.
Thank you so much, Frank. That was awesome. Appreciate you. I know we appreciate you rushing through it a little bit so that it saves time for us all to get some interactive parts going later on in this. And yeah, we'd love to encourage anyone to throw some questions into the chat. What are we interested to know when it comes to either the grid or green buildings that potentially Frank could shed some light on? And Frank, maybe I'll just kick us off with one question here that comes to mind for me is like, if you're a building owner, what would you say is like the one or maybe two like high impact things you could do to improve your either energy efficiency of your building or sort of somehow decrease your reliance on the grid?
I would definitely be, I buy power from. There are a lot of incentives out there, a lot of rebate programs, a lot of financial assistance out there that's already available for building owners to take a look at and find ways where they can afford these changes. And, we know that, for example, Mayor Garcetti for the city of Los Angeles recently released the Green New Deal for Los Angeles. And within there, you can take a look and you can find now there's a bunch of plans to increase funding, increase programs so that building owners can purchase the right retrofits that they need for their building to help achieve a net zero carbon and net zero energy future. Because ultimately what works for the owner of these buildings, right, is if you're reducing the cost of energy and you're reducing your operational costs over the lifetime, you get a payback from that. And to specifically answer your question, a lot of things that building owners can do that happens often is a lighting retrofit is a great way to help reduce your energy. Putting in a smart lighting system too, along with the lighting retrofit, because that sets you up for a future of Internet of Things, the future of 5G, where everything is communicating, talking to each other. To be able to put in that smart tech on your systems is a great way to just start off with like maybe a lighting system. Then, like I said, talking about imagining your building to be dynamic and be able to communicate with other systems. Those are the sort of retrofits or changes, or even not even for new constructions. Those are the features that you want in your building.
Thank you so much for that. I really appreciate it. Waiting to see if any questions are going to trickle in here. We'll give it another couple of minutes and see if anyone has any questions. Sometimes it takes a minute to formulate a question, so I totally understand if that's the case for you guys.
Yeah, in the meantime, I'll go in and dive a little bit deeper into some of the concepts I was talking about. And so we were talking about the density of buildings and having the limitations of photovoltaics and where they're at. I can imagine the suburbs that we have communities that can cover up their parking lots with photovoltaics, having large commercial buildings install batteries maybe in their warehouse area, or having battery storage somewhere. It's going to take a community approach, having your local city or your jurisdiction to work on its own energy and to own its own energy. the business model of having this top-down approach is slowly aging and isn't going to be the right type of business model for this, net zero carbon future. So what I ask for the whole audience to look into, and I think these discussion topics we'll get into, is the idea that, what can you do for your community to help bring in a microgrid structure to have clean power for yourself?
Fantastic. Well, thank you, Frank. So let's see. So Rebecca's got a question here. It looks like Tom had a question. Okay, so I'm going to read off Rebecca's question here. So who should we reach out to encourage electrification and steer away from natural gas? Government, utility companies, your landlord? What are your thoughts, Frank?
Yeah, so Santa Monica and West Hollywood have recently been really great trailblazers to show that they are going through the process of pushing in what's called REACH codes and showing that what their electrification of buildings is going to be cost effective, that they're not trying to push down the cost or the cost and burden to the consumers, the people who are going to be living in those buildings. If you type in, if you're looking for REACH codes, I know that Southern California Edison is a great sponsor of, of course, they're the electrical utility company, right? So of course you're sponsoring this, but they are looking for ways to work with consumers and looking for ways that, how do you make electrification very affordable? But at the same time, we want to also be really conscious about what electrification means for the communities, especially for communities that don't have the financial means all the time, or lower income communities. We want to make sure that we put in the right technologies that don't make gentrification a worse problem than it already is for some communities. So we need to take a look at the equitable situations that we can install in all communities and make sure that everyone has access to clean energy and clean power.
Thank you, Frank. Okay, so Tom asked a question. So, sorry, Tom, I'm trying to, software to measure plug loads. Any sort of, Tom, do you want to, I'm trying to, Tom, I don't know if you have the ability to ask the question out loud.
Yeah, I think so. So one of the things that I ran across earlier when I was up in Portland especially was the use of phase change materials. It's kind of like, I mean, they're like bubble wrap almost.
Yeah.
Material in it, and I know it was tested in a couple of places with very, very good results. It's much thinner than insulation. I'm wondering if that's being rolled out in a larger fashion now.
Thanks, Tom.
Yeah, so I can definitely answer that question. I personally worked with phase change materials before. Actually, in my college career, I created a cold storage situation where we use phase change material. And actually, the phase change material we used was agriculture. It wasn't from fossil fuel. So we try to make it was a vaccine cold storage device, and it was trying to be sustainable. Anyways, so yeah, I'm really aware of phase change material. They're pretty common. I wouldn't say they're pretty common, but they've been used a lot in Europe, and Europe has been able to kind of trailblaze in that sort of technology. In the United States and California specifically, it gets a little bit more dicier. You can say what you want about regulation, but like that sort of technology hasn't been explicitly approved for like the energy code. And so if you were to, the problem is sometimes that we see in regulation is that there's some great technology out there, but it might not be incorporated into the energy code as like a credit or such, you won't get any sort of like, brownie points for using such great tech, because the energy code doesn't really know how to like deal with that sort of like technology and make sure that it's used in a responsible fashion. So I think when there's great technology out there, there definitely needs to be a way to fast track some of these innovations so that it's more accessible and much more common, or it's sanctioned by the states to be used readily.
Awesome. Thanks, Frank. I think we got time for one more question. So we're going to take Tyler's, and Ning and Kevin, we will be sure to try to answer those questions post event and get those out to everyone. So Frank, Tyler's question was, he said, thanks for the great presentation. I've been focused on implementing community choice energy in my hometown for the reasons you described. My question is about whether you think a community choice aggregation program can own generation facilities, or if they will simply engage in long-term power purchase agreement contracts for generation.
Oh, that's a great question. I wanted to get into like the clean power alliance and the community choice energy. It is a hot topic right now. Maybe not for a lot of people, but in the energy and the energy regulation world, it is sort of a hot topic. It is, you're at the fundamental idea of it. You are taking power away from utility companies, and of course, where there's power, there's money. So there is a economic and political game that needs to be played there. I'm not going to touch on too much of it. I'm going to avoid politics, but the idea is that, in some true sense, when it comes to the communities having their own generation, that sounds like a great idea for communities to own what they can. But at the same time, when you're working with a microgrid situation, you have to realize that you're supporting other communities and also the entire infrastructure of the grid. So whether they can truly own their generation is yet to be seen, partly because at some point in time, it all needs to be operated together. Someone needs to be able to manage all these things together. And so while you might own the PV on your roof, or your city might own the PV in its area, it might have to let go of some of its authority or ownership so that other communities can rely on that power too. Because the idea is that we have to be able to share microgrids. When one community can't produce enough power for whatever reason, the other communities need to be able to push in and help to generate that clean power. So I'm definitely an advocate for communities to have that sort of like community-based approach when it comes to their power and like having that sort of infrastructure. But also at the same time, we have to realize that if there is a blackout in Northern California because of fires, that maybe the Central Valley has to lean in their power, and they might have to give up some of their authority to share power to another region or territory that's that's weatherizing a natural disaster or weather event.
Thank you, Frank. Great question, Tyler, and thank you to everyone for putting your questions into the chat. We really appreciate it. So at this point, we're gonna go ahead and move into the breakout room discussion portion of the event. And I'm gonna post the first question into the chat. We encourage, I see some cameras flicking back on. We encourage cameras so we can see your beautiful faces. And yeah, it just makes for a little bit more of a personal experience. And so I'm going to drop this first question into the chat here, and then we'll send you out into breakout rooms. There'll be about 4 or 5 of you in a room, and it'll be 8 minutes. 8 minutes for the discussion. We'll come back out. We will ask you to type your takeaways into the chat. We'll go out for one more discussion prompt. So with that, I'm going to go ahead and drop this question into the chat and read it off to everyone. Bear with me here. All right, here we go. So the question is, discussion prompt number 1. Have you ever looked into or participated in community level energy efficiency programs offered by your city or utility? If so, what was offered or what was it like? And if not, are there any that you've heard of that interest you? So I'll read it one more time. I know it's a multi-layered question. Have you ever looked into or participated in community level energy efficiency programs offered by your city or your utility? If so, what was offered or what was it like? And if not, are there any that you've heard of that interest you? So with that, I'm gonna initiate the breakout rooms here. All right. Great breakout rooms. Open it up. All right, I'll see you all soon. enjoy. All right, welcome back. Welcome back. Hope everyone enjoyed that. Looking forward to hearing about what was discussed. So at this point, if you can think of a takeaway from the discussion, we'd love for you to type it into the chat. We'd love to hear, I would love to hear what you were talking about in there. And yeah, if anyone would like to share, that would be really great. We'll just give you a minute, and then before we introduce the second discussion prompt, and go out for one more round.
Sorry, I think we joined after you started talking. What did you say? Type in like the main points?
Yeah, any takeaways would be awesome. What do we got? Okay, Rebecca says rebates, Flex Alert, and OHM Connect. Tyler says, we talked about programs from utilities that give cash back to residential customers for doing things like adding an EV charging station or a smart thermostat. Huh. Let's see what else we got here. Anybody else? Tom, and the effectiveness of having a customer advocate to help people through. And Kevin says, local gas and electric company PG&E up in Northern California gives residents the option to purchase a portion of total energy from renewable sources. Price seems comparable, which makes me desperate to purchase more. I feel that. Very cool. Okay, let's see. Oh, Gabe says, we discussed how apps like Flex Alert and OHM Connect are empowering to the people. And Tyler added, I'm also aware of a program that was implemented by Sonoma Clean Power, which gave people $10,000 to $20,000 to rebuild their homes, which had gone down during fires if they build all electric. Oh, what a cool deal. Okay, awesome. Well, thank you all so much. I appreciate you sharing those. I'm gonna go ahead and drop the second discussion prompt in here, and we'll send you back out for the next round here. Okay, so prompt 2 is, what energy efficiency improvements have you made or would you like to make in your own life and home? So I'll just read it once more before we open back up the rooms. What energy efficiency improvements have you made or would you like to make in your own life and home? All right, I'm sending y'all back out. We'll see you soon. Enjoy. All right, welcome back. Looks like people are still trickling back into the main room here. Yeah, anyone have any takeaways they want to share into the chat before we wrap up? Yeah, it looks like most of us are back now. So for me personally, I'm thinking LED light bulbs, solar if I could afford it, battery storage. I'm wondering what came up for you guys in there. Power walls? Give everyone a vehicle to grid. Love it. For those of you,
I was just saying, our breaking groups spoke a little bit about heat pumps and differences between LA and BC.
Heat pumps, Nick says, putting the majority of plug-in appliances and personal electronics into power strips to present present vampire energy draws. Let's see. Tyler says, EV to grid is great. Solar and heat pumps. Tom says, Rebecca said, reduce vampire energy. I need to get familiar with this vampire energy situation. With power strips, reduce embodied carbon by buying in bulk and reduce deliveries, sealing the building envelope, and heat guns to find cracks. Thank you for sharing that, Rebecca. Gabe says small choices that everyone can do, even people who don't own their homes. Yeah, that's the boat that I'm in. Kevin says smart thermostats, weather stripping, motion sensors. A lot of good ideas in here. This is cool. Well, thank you all so much for sharing these. Really appreciate it. So at this stage, while it looks like I've got some of you on camera here, I wanted to, just before we wrap up, see if we could get a quick group photo. Is everyone okay if I snap a quick shot? Yeah, okay, awesome. Thank you so much. All right, let me see. We get a little wave going. I'm gonna throw a shaka like I always do. All right, here we go. And we got it. Okay, thank you so much, guys. Okay, so let's see here. Before we all head out, just want to let you all know about the Net Zero Conference. So that's put on by Verdical Group every year. And it's happening this month on next month on September 15th and 16th. And I'm going to be there. I went last year to the in-person event. It was so much fun. I learned a lot. The keynote speakers were fantastic. Met a lot of just interesting people. And I've said this before, but just getting in the same room, kind of like this, with people that are all like-minded and you know, sharing this worldview of you know, climate change being such an urgent and important problem to solve, and us wanting to be a part of it. So can't recommend that highly enough. I'm going to drop into the chat here the website, and also discount code, so it's 10% off for anyone who would like to go. Myself and Kevin are going to be attending. We're really looking forward to it, and Chloe and Franca, of course, will be there, and yeah, we can't wait for that, guys. Let's see, what else do I have here before we wrap up? Next month, we'll be hearing from Nick Doyle of Tomra Systems, who's also here in the audience with us today. Hi, Nick. Yeah, so he's going to be talking about optical sorting technology used in recycling and a vision for a circular economy. So we do hope that you will join us back here next month. I know there's some faces that I've seen before, so I hope you guys will join us again. And as always, thank you so much, Kevin Wallner, for being you know, a part of this and helping us coordinate these events. And with that, that'll conclude our show, but we will be sticking around for a post-show additional event prompt. So we'll kind of let anyone who would like to head out and get on with the rest of their day do so. And then in about 30 seconds or so, we're just going to stay in here in the room together and kind of go through one more discussion prompt. Thank you so much for coming, everyone.
Thanks,
Thank you, everyone. Really appreciate it.
It was awesome.
So here's the last thing we thought would be fun to discuss. So what are some energy efficiency related efforts you've seen businesses take to do their part in lowering their reliance on the grid? And anyone is welcome to kind of jump in, unmute yourself and jump in if you've heard of anything interesting in that regard.
I'll start. I was actually telling Chloe and Brian were actually both in my room, and I used to manage a Sierra Club lodge in Lake Tahoe that held up to like 400 people. And one of the first things I noticed when I started working there was in some industries, you have to keep the lights on, whether it's a commercial office space or hotel. There's a lot of things you have to do. Like you have to keep the whole thing warm, even if only 12 people are staying there that day. It's gut wrenching, but we found out pretty quickly that there's a local electric company offered huge discounts on LED bulbs. And I did like year-over-year analysis after a few months of kind of gathering some data, because I love data. We saved like something like 40%, at least 40%. And this is a rough estimate, but we saved significant money on our electric bill from that. I thought that was incredible. And you know, it's funny because we had to be the ones that go out and find the information and learn about it. That maybe there's a couple little like advertisements in town that you might pick up on. But it didn't take that much energy, or no pun intended, to figure out how to save energy. So I thought that was cool. But I would have loved it if the local, I think it was the business council, would have tried even harder to go out and just like literally tell every business in town, like, what are you doing not buying these LED bulbs? You have bulbs, you can get rid of them, you can save money, they'll pay themselves off. So
And the LED bulbs last for like a decade or more.
And they don't explode when you break them.
I know one of the big energies, I'm not articulating that correctly, but refrigeration is huge in terms of power usage. I'm not really sure anyone's addressed that with any sort of innovation. I think I heard recently that there's some sort of new refrigeration method, not using a compressor maybe, but I don't know if anyone has any experience with that or knows anything.
I've done a cold storage project. Oops, sorry. I talked enough. I'll let someone else talk.
Go ahead, Spencer.
I was going to say that, I mean, what makes that problem even more complex is the fact that that on top of like refrigeration just taking a lot of energy, the actual refrigerants that are in use are horrible greenhouse gases. Like it was something like the CFCs or whatever their replacement were, like even the ones that don't degrade ozone, they're like, what makes them good at refrigeration is the fact that they retain heat. And so when you dispose of them, unless they're like captured properly, these things just leak into the atmosphere. And you have basically what's like a 1,000 time density of just like over carbon dioxide leaking into the atmosphere. And so it'd be really cool to start something to capture that, like just a refrigerant recycling program, because I feel like that's something that I learned about like 2 months ago or something, and I'd never heard of it in my life, so I don't think that many people even realize.
Yeah, and there is a refrigerant future. There's new blends that they're currently in development. The EPA, the United States EPA, has been, relatively very successful at trying to push the innovation of refrigerants, and they have these new blends. So we're used to like R22 and maybe R410A as refrigerants for HVAC systems, and the cold storage uses like ammonia and other stuff. But there are these new blends that have really crazy names that are way better for the environment when they leak out. I don't know what their embodied carbon is to produce them and manufacture them, but definitely when it comes to cold storage, because those cold storage needs to be cold 24/7. There is innovation out there to make more efficient compressors, because they consume a tremendous amount of power. Believe me, they can consume so much power. And when you consume power on that level, there's always someone looking for a way to shave off a few, make their compressors a little bit more efficient, because that's hundreds of thousands of dollars in savings.
And I think there should be, there's not a current incentive for like end of life disposal, but I feel like a lot of the refrigerants that Spencer's talking about leaking into the atmosphere are coming from fridges that have been abandoned in landfills and sort of wait till like their parts rust out and it just escapes in the atmosphere. There's got to be some sort of innovation where you can detach the compressor or the container of refrigerant fluid and dispose of it in a better manner. But I think that's kind of not incentivized for any manufacturers, but that's something that I think, government regulation would be good.
Well, funny enough, I think so far the refrigeration capture management has been relatively successful. There's actually a market for there's some old chillers for people who have not upgraded their equipment yet, and they still operate on like bad refrigerants because they stopped manufacturing the older refrigerants. That the capture of decommissioned chillers or equipment that use the old refrigerants, that it's like kind of a gold mine. They have to capture it because someone will buy it for 10 times the price, because they refuse to, unfortunately upgrade their systems to better equipment. They're still using the older equipment. So because they don't manufacture the old refrigerants, anything that's left, anything that's still out there in the wild, in a random building, the capture that, it's almost like liquid gold for some people. One man's trash is another man's treasure, right?
Interesting stuff. Alex, appreciate you bringing up the topic of refrigeration. I'm curious if Ning or Nick have anything to add on this topic, on
Yeah,
on the question, the prompt.
I do actually. I have a few examples of companies that have taken pretty substantial strides to reduce their draw from the grid, and it's all in the form of biomass, woody biomass, and organics, right? And so the first company is cool. I forget the name of the company. They're a walnut farm up in Northern California, over by Sacramento, just north of Sacramento. I think it's by Davis, actually. What they do is they shell their walnuts and then sell the nuts in unshelled form. And what they do is they take those walnut shells and put them into little combined heat and power biomass gasification systems, and are able to turn those shells into renewable baseload electricity and heat. And they're able to utilize that heat and electricity for their various handling processes, right? One of the uses for heat is to dry the walnuts out and prepare them, cut all the mechanical processes, buildings, offices, you name it. They use it to power their entire facility, and they are off the grid entirely. So in the terms of that, and with biomass and these alternative fuels, they're particularly useful for organizations that are in more rural areas where they don't have access to a local power distribution network, right? They have to bring all of that energy in. And so that's expensive. The second company example is BMW down in Spartanburg, South Carolina. What they do is, so that facility in Spartanburg is BMW's largest manufacturing facility in the world. But what it is really is a assembly plant. So what they do is they take all of their cars and ship them over in these big beautiful pine and oak crates and on pallets, ship them in parts, and then assemble it at the plant, and then export it out to market so they can take advantage of tax credits. And what they do with those pallets and crates is they break down that wood and use it as fuel for biomass wood chip boilers to offset their heat natural gas demand, because they use a tremendous amount of heat. And while it is just a drop in the bucket for them, they are able to divert all of that wood waste and turn it into fuel to power their systems. And then the last example.
So do they capture the carbon from the smokestack from the wood, or is it just that sort of secondary?
Yeah, they have to. I mean, in order for these systems to operate, you have to have a lot of bag houses and filtration systems to make sure that you're not releasing any carbon or VOCs, nitrous oxide, SOx, that sort of things into the atmosphere. The thing is to make.
But they're still releasing some carbon dioxide.
Yeah, I mean, you're going to have some carbon dioxide because it's a combustion process, but these are things, these processes, they're improving, right? So eventually we'd like to get away from combustion, right? But in a lot of these cases, you need to have a small combustion aspect to it to allow for scalability of these systems. Otherwise, if you have no combustion, it's no oxygen, you need a much larger processing capacity in order to achieve that economies of scale you need. But the third example, and again, it has to do with what is equestrian centers. There are two equestrian centers in the United States right now, one that's going in Ocala, Florida, and another in Wilmington, Ohio, both that use horse bedding from their equestrian shows, and they're able to pelletize that and again use that for CHP and wood chip boilers to power their facilities. So, I mean, there are one big push right now is utilizing methane from anaerobic digestion, organic waste, as well as methane taken off from landfills to power facilities, and to also reduce the need for electrical gas-fired appliances, or the demand rather.
Actually, the methane landfill generates carbon offsets, but they're actually carbon-positive carbon offsets, which I think is interesting. That you can have
carbon positive, so they're adding carbon to the, yeah.
But they're reducing the amount of methane, and methane's like 270% in the last 2 to 4 years. So it's actually they can generate offsets while still releasing carbon, which is a little bit fun.
Yeah, it's
That's
the methane capture is incredible. I mean, because it's such a, as you said, it's such a more potent GHG than CO2, but It was the UN that had said in 2013 that organic waste is the third highest contributor to greenhouse gas emissions behind the US and Chinese economies. So it just goes to show that methane is a very potent and devastating GHG. And so if we're able to recover that while it is carbon positive, you kind of have that, okay, if not this devil, then that one, right?
Well, thank you, Nick. Appreciate you sharing that, man. I'm wondering if John, Chloe, or Ning have anything to add or share on this.
I'm just listening and learning.
I think what's interesting, I'm just kind of stepping back a little bit. I think as consumers, right? Like not everybody works in a B2B environment where we understand a lot of these industries, these verticals, and the inputs and outputs of their industry. So I think as a consumer, right? Like I consume products and services, and I don't really know all the different kind of things, the externalities, right? The things that they put off. Like I wouldn't even think about these big wooden boxes, right? Or all the bedding required for equestrian centers. And so I think where I'm going at is like, it's cool to see businesses and industries understand that they are putting something out there in form of output and finding a way to take advantage of that instead of just walk away from it, right? And I think that, so it's like the opportunity, right? It's almost like they're missed opportunities. Like the opportunity is to figure out what you're kicking off as a result of making your product or service, and find a way to use it as energy, because some people have figured it out and it's actually allowing them to be off grid or totally sustainable. I wonder how many other businesses and industries out there are not taking advantage of this opportunity because they don't even realize that there's some process or method created or in the process of being created to help capitalize on what would otherwise have been completely waste. It's just fascinating.
Well, you have the entire Central Valley of California. That's a good start. Every business there, every agricultural center. I mean, the Wonderful Company is a great example, right? They produce hundreds of thousands, not millions of pounds a year of almond hulls, pistachio hulls. Every 12 years, those almond groves, they hit their maturity, and what do they do? Instead of letting them grow, they rip up all the almond groves, up all those trees, and then just plant new groves, and then they pile all that biomass up and let it sit and decompose. And then what is it? The South Bay and the Bay Area AQMD and the San Joaquin Valley AQMD have scheduled open burn days, where they take all that biomass and they dump it in a field and then torch it. And the funny thing is, how can California sit here and claim to be so stringent on their air quality mandates when they're sitting here torching perfectly good fuel and contributing and releasing all of that carbon into the atmosphere? Right.
I think that's where tech can really help us optimize this industrial or agricultural processes. Because there are some businesses, for example, like long distance trucking, where the value from the business is generated basically directly from fossil fuel. The fossil fuel allows you to pull a tractor trailer full of goods to another place. But there's this whole other sector of the economy, a lot of production, a lot of agriculture, forestry, where there's this room to optimize these processes and generate either, energy from waste or and Spencer got eaten. But I think tech really gives us an opportunity to identify and optimize those processes.
Thanks, Alex. Thank you, everyone. All right, you know what? I think with that, maybe we will go ahead and call today. We'll go ahead and wrap up here. I just want to say thank you so much for sticking around after. It was great to see you again. Alex, nice to meet you. I'll definitely get back to you. And Frank, great job today. Chloe, so happy that you've made it. John, Kev, Spencer, Nick, you guys, this was awesome. So if anyone has any questions or wants to follow up about anything, please just drop us a line and an email or wherever, and we'd love to keep the conversations going.